My name is Pavel and I'm with Graph1. I'll be talking about the Lightning Network, what it is, how it works, and how it can benefit Bitcoin. First, let's go over the why. So Bitcoin has seen transaction growth, reaching the maximum amount of data per block. This occurred a couple of years ago. Right now, the maximum amount of data per block is about 1 megabyte. And the result of this, what happens? Well, we get into the situation where fees spike. During the last boom of 2017 and spilling over into early 2018, we saw this really large increase in fees as people were trying to get into the next block or next couple blocks, and they were willing to pay large amounts for that. At some points, almost $40 per single Bitcoin transaction. So this is an issue. So a couple of solutions were debated and proposed over the years. And there were two main camps. One wanted to increase the block size from 2 or 4 or to an unlimited number. And another wanted to create a second layer solution. So something like the Lightning Network or sidechains. The block size increase group saw their solution as simpler, although it would require a hard fork, meaning that once the protocol is changed, all the nodes that were not on the new protocol would likely become a new coin. Also, there was a large risk of centralization of hardware. When you change the block size, you would often need more powerful hardware. So that means that an average user might not be able to run a node anymore. And it could be limited to large companies with data centers, which would obviously negatively impact the decentralized nature of the network. And again, it would require additional hard forks when the block size is full again. So you'd be repeating that process. So if they moved it to 2 and it filled up to 2, then they need to hard fork again. The analogy I like to use is their solution was kind of like adding lanes to a highway in terms of adding capacity. So for layer 2, this would entail creating a completely new protocol. It would mean a soft fork versus a hard fork. So the nodes that haven't upgraded wouldn't necessarily split into their own coin. It's a bit safer and better for the network. It doesn't alter Bitcoin's decentralized properties. So someone who's able to run a full node before these changes would likely still be able to do the same after. And it was seen as a more of a long-term solution to these block size issues. I liken it to something like high-speed rail, public transportation. What eventually happened was there was a split. So the people that wanted to increase the block size actually did hard fork and they created their own coin, which is Bitcoin Cash, in August 2017. Bitcoin decided to soft fork some of the upgrades into SegWit in July 2017, and then the Lightning Network itself was on mainnet by that next January. As you can see over the past 18 months or so, we've seen a bit of growth in terms of people operating Lightning Network nodes and in terms of the amount of Bitcoin on that network. So what is a second layer? Both Lightning Network and sidechains are a second layer on Bitcoin. So they require Bitcoin and they interact with Bitcoin's protocol. But there's no changes to Bitcoin's base layer. In essence, they maintain their own network and they offer alternatives and additional features. The second layer is completely optional and it's not required to use Bitcoin itself. A comparison would be like an expansion pack to a game, whereas you need the base game to play the expansion, but not vice versa. And a more relevant example in Bitcoin's history also is Magic the Gathering. So what is the Lightning Network? Essentially, it's a series of payment channels. A payment channel is something like a multi-signature address that acts as a smart contract. In this case, Bob commits about 0.5 Bitcoin to a payment channel with Alice. It's a multi-signature contract, so they both sign this channel. And an opening transaction is shown on the Bitcoin blockchain. Bob and Alice also have a separate Lightning Network kind of balance sheet of this opening balance. Now say Bob wants to pay Alice through the Lightning Network. What happens in this payment channel is Bob's balance sheet is decreased by 0.1, whereas Alice's is increased by 0.1. They both update their copy of the balance sheet. Bob and Alice can transact between each other through the Lightning Network without actually needing to broadcast a transaction to the blockchain. So this transaction here is actually not shown in Bitcoin's blockchain. It's only through Lightning Network. When Bob and Alice are done and they want to close a channel, that's when they broadcast the latest balance sheet to the blockchain. So in this example, say they want to keep transacting with each other, sending Bitcoin back and forth, they can do that. In this example, only 2 times is the actual Bitcoin network fee paid: when they open the channel and when they close it or settle out their balance. As long as the balance on either side is above 0 at any point, they can keep transacting through Lightning Network without needing to broadcast to the blockchain. And the fee that they pay per these transactions is kind of set by each node. It's not the standard Bitcoin network fee. Where the network part comes in is where you can have channels with multiple parties. So in this instance, Alice also has a channel with John. Now say Bob wants to pay John. Even though Bob doesn't have a channel with John, he can still pay him through Alice. So what happens is, in Bob's channel with Alice, 0.2 Bitcoin gets pushed to her side in terms of their internal ledger. And in Alice's channel with John, 0.2 Bitcoin gets pushed to John. So in essence, Bob has paid John 0.2 Bitcoins, and Alice's balance has remained essentially the same. So you can send funds through a third party. Now, there's something called HTLCs, or hash time locked contracts, which prevent a party in the middle from being able to just steal the funds when they're being sent like this. And there's a specific amount of rules that prevent them from doing so to make it secure. In terms of the network, the routes are shared via something called a gossip protocol. So each of these nodes kind of talks to each other, and they basically share a map of where the other nodes are, so you can find a path to payment from Bob to Alice. Nodes determine their own fees. Some nodes may say, I don't want to charge any fees. Some nodes say they're a really quick path, or they're a shortcut, they're popular, may elect to charge higher fees. It's almost like a toll road, right? If you have a really efficient and short toll road, people may be willing to pay for that. Anybody could run a node, and anybody could create channels. And at any time, if there's a dispute, you can always broadcast to the blockchain. In terms of frequent or high volume transactions, a lot of these can be done through Lightning Network without taking up that precious block space, which we're limited to 1 megabyte of. Of course, larger transactions could always still be sent the regular way, especially if you're willing to pay a couple dollars for, tens of thousands or hundreds of thousands in value being sent, and if you're willing to wait for those confirmations. Some differences. So the Bitcoin network fees are completely independent from Lightning Network. So if there's a $10, $50, $100 spike again, it could still mean you could go on the Lightning Network and send 1 cent through for a really small fee of like a thousandth of a cent. Payments need to have a valid route, so they need to consider things like the channel size and balance. With a regular Bitcoin payment, all you need is someone's address, and then you just send them Bitcoin. With Lightning Network, you need to make sure that there's a proper channel size and balance to go through. In this simple example here, for a payment from A to B, if you want to send 0.2 Bitcoins, you can only go on the top route, because on the bottom route, you run into a bottleneck at the green line there, where there's not enough channel capacity. To receive payments through Lightning Network, nodes have to sign transactions, so you should be online. And then there's also services like watchtowers, which protect against things when you're offline. And transactions are pretty much instant. So you don't need to wait for any confirmations to have secure payment that you can start spending that again. Also, there's some extra privacy in this because all of your transactions aren't shown on the ledger for everyone to see. That means you more or less have a degree of privacy. Some limitations. So channel openings do have some minimums. Sending tiny amounts is possible, but there is a risk there that if the amount you're trying to claim is lower than the Bitcoin fee, it might not be worth it. Also, rebalancing solutions are still being developed to ensure proper liquidity, so it's not automatic in terms of being able to find a path. There's some manual work involved at this point. And spam and DDoS attacks still possible. These nodes, they have their IP addresses often revealed. And multipath routing is not yet implemented. So what I mean by multipath is the way it works now is if A wants to send a payment to B of 1 Bitcoin, it goes 1, 1, 1, 1. In multipath, you can split that 1 into 0.5 and send 0.5 this way and 0.5 that way, which would obviously make it easier if you have a bottleneck here where the channel size is only 0.5. We have some proposed solutions for that, but at the current state, it's not implemented. But there's a lot of potential. Instant, secure transactions means vendors don't need to wait. So there's a lot of benefits to commerce, trading, and other services being developed. Incredibly low fees also lowers the threshold for minimum transactions. Comparing that to something like a debit or credit, where it's only worth it to the merchant for something over that minimum, which is like 25 cents per transaction. Essentially, it's almost like infinite transaction scaling. You can scale to thousands, millions of transactions per second. And in terms of a medium exchange in developing nations, it gets rid of some of the barriers or disincentives for doing smaller transactions. For example, you want to buy a cup of coffee for $5. Well, if the network fee is $10, you're not going to do that. With Lightning Network, your fees are potentially minuscule, so you can start using Bitcoin as a medium exchange again. Also, for things like fast food or other services where you need a instant settled and secure transaction, you don't have time to wait for those confirmations every 10 minutes. So with Lightning Network, once you receive the money, it's secure and you can start spending it again. And there's a lot more services that are coming online all the time. There's light mobile wallets, same as any kind of phone wallet that you can have on your phone. You don't need the full Bitcoin blockchain on there. There's autopilots, which basically automatically connects your wallet to a channel, so it makes it easier for you to start using Lightning Network and paying and receiving. Channel rebalancing services are being developed. And of course, things like crowdfunding, tipping, sending gifts and vouchers are all possible through Lightning Network. For merchants, there's payment processors, of course. And then there's things like digital arts and games that are being developed for the Lightning Network. And of course, traditional things like brokerages and exchanges as well.